In this video, we will derive the formula for cos of x minus y, that is the difference of two angles, and apply it to derive the value of cosine of 15. Cosine of x minus y is equal to cos of x times cos of y plus sine of x times sine of y. So this is the formula for the cosine of difference of two angles, and we'll see how we arrive at it. We use the Euler's formula e raised to I times x is equal to cos x plus I times sine of x, where I is the imaginary number square root of -1. So e raised to I times x minus y will be equal to cos of x minus y plus I times sine of x minus y. And we are going to use this expression for deriving the formula for cosine of x minus y. E raised to I times x minus y can be written as e raised to I times x minus I times y using the distributive property. Now e raised to ix minus iy equals e raised to ix upon e raised to iy. This is using the laws of exponents. So this will be equal to cos of x plus I times sine of x whole upon cos of y plus I times sine of y. And when we multiply this by cos y minus I times sine y and divide it by cos y minus I times sine y, that is multiplying by suitable one, we will get cos of x plus I times sine of x upon cos of y times cos of y minus I times sine of y. So this is the expression we are going to use to derive the expression for cos of x minus y. Because when we expand this, we will get terms which do not involve I and terms which involve I. We have seen in our last video about sine of x minus y that we obtained sine x minus y using the coefficient of I in this expression. So cos x times cos y plus I times sin x times I times sin y. So I square sin square y is what we are going to get when we expand. Now negative I square sin square y is just the positive of sin x sin y. And that's how we get the formula for the cosine. So if we equate the real parts of the two expressions, e raised to I times x minus y is equal to cos of x minus y plus I times sine of x minus y, and the expression that we obtain by expanding cos x plus I times sine of x times cos y minus I times sine of y, we arrive at the formula for the cosine of difference of two angles. Cos of x minus y equals cos x cos y plus sin x sin y. So this is how we obtain the formula for cosine of difference of two angles. The formula for cos of x minus y is quite important in useful in solving many problems in trigonometric identities, as well as it is useful in wave optics and electricity and magnetism areas. Using this formula, we are going to find out the value of cosine of 15. Since 15 is equal to 45 minus 30, we will have cos 15 is equal to cos of 45 minus 30, which equals cos 45 cos 30 plus sin 45 sin 30, using the formula for cosine of difference of two angles. Now cos 45 and sin 45 equal 1 over root 2. This is obtained from the isosceles right angle triangle, and the values of cos 30 and sin 30 are square root 3 by 2 and 1 by 2 respectively, which are obtained from the 30 60 90 triangle, which in turn is obtained from the equilateral triangle by dropping a perpendicular from vertex to opposite side. Using these values and taking out 1 over 2 root 2 common, we see that cosine of 15 is equal to 1 over 2 root 2 times root 3 plus 1. So this is the value of cos of 15. There's more to come on trigonometry and trigonometric expression and identities. Stay subscribed. Thank you for watching.